Okay, so now that we have some knowledge on how to create our own functions in Matlab, let's solve one last example problem. So the example problem we'll be looking at in this video is this one here. So this says the Rayleigh distribution has a probability density function given by this equation, and we have two tasks. The first one is to create a function which evaluates the Rayleigh distribution for a varied number of sigma parameter values, so this variable here in this equation. And our second task is to create a separate function which plots a distribution function by first calling the function created in task 1. So this video will focus on solving this part of the problem, and the next video will focus on solving the second task. Okay, so let's just jump straight into it. So we have our new script here, and let's create a function. So we know that we need to use the keyword for function, which is function. For the moment, let's not specify any outputs. Let's give it a meaningful name. Let's call it Rayleigh. For inputs, if we go back and have a look at the problem itself, it says we're creating a function which evaluates the Rayleigh distribution for a varied number of sigma parameter values. Okay, so it should be obvious that this sigma parameter value here will be our input to this function. So let's make an input to this function and let's call it sigma. Okay, we'll give it a quick description. We'll say Rayleigh calculates the Rayleigh probability density function, PDF for short. Okay, so in order to evaluate this function using Matlab, we're going to have to set up some data points which will be used for x, and we do this using the linear spacing function, or linspace. So let's set that up now. Now for our minimum data point in the linspace function, this equation here specifies that x must be equal to or greater than 0. Okay, so let's let our minimum be equal to 0. Let's choose an arbitrary value for our maximum, which is 10. Let's give it 500 data points. I'll just include a quick comment here about this line and why we're using it. So we'll just say generate the data points used to calculate the distribution function. Go ahead and save that, remembering that the file name of our function must be the same as our function name, so in this case Rayleigh, so we can save. Now in order to reduce the number of lines of code that we use in this function, we'll use a vectorized version of this function that we're about to put into our Rayleigh function. And so this means we're going to have to create matrices for the Rayleigh function variables, which in this case are x and sigma. Okay, and so to do this, we're doing this so we are able to vectorize this equation, and to do this we're going to use the mesh grid function. So let's go ahead and write a comment. So say, in order to vectorize the distribution function, create matrices for the Rayleigh function variables, which are x and sigma. So once again, the x value of this function will vary, and we know we're varying the sigma parameter values because that was defined in the first part of the problem. Okay, and so to do this we have to create two new variables. Call this one capital X and the next one sig with capital letters. Let this equal to mesh grid of x and sigma. Okay, so now we can go ahead and write this equation as vectorized code in our function. So jumping straight into that, we'll let it equal f. Now we're going to be using the matrices that we created using our mesh grid function, and remembering to include full stops for matrix multiplication and division operations. So this code here, so we've got x over sigma squared, which corresponds to this here. Now I'll go ahead and put the rest in, remembering the full stops for our vectorized code, and I'm also including a large number of brackets just to be safe. I'm just finishing up here. Making sure all our brackets match up. Putting a quick comment here. We'll say calculate the Rayleigh probability density function for a list of function parameter, which is our sigma values. Okay, so now that we have this function, let's consider what the outputs might be. So if we were to plot this function, which we are, we're obviously going to want our function values, which are indicated here as f. So let's include this as an output. Let's also include our x variable, so the data points that we generated using linear spacing, because if we want to plot it, we're going to want the x data points as well. Okay, so we'll save that. We'll go to our Matlab script and we'll just create a random variable which will be our parameter inputs. We'll just go from 1 to 3 in, so 1 to 3 in steps of 0.5. So generate 5 sigma values, so this is our varying parameter. And then now we'll call our function and we'll return we'll return the output under the function name m, and we'll use n, for example, as our x data points. Now entering the function, we can pass in sigma. Okay, so at the moment it doesn't do a whole lot, but we can see we've got the function values which are stored in m, so that's the output, and that's a 5 by 500 element array. So that 5 corresponds to the number of varying input parameter values. So we have 5 here, and 500 is obviously the amount of data points we used to evaluate our function. And n, of course, if we just have a quick look, are the steps from 0 to 10, and there are 500 linearly spaced increments. Okay, so we can just quickly plot m and n. So n against m, as n contains our x variables and m contains our function variables, just to see what we end up with. Okay, so we can see we're getting some neat little graphs here, some neat little plots, and so that concludes task 1. We've created a function which evaluates the Rayleigh distribution for a varied number of sigma parameter values, and so the next video will go on to task 2.